So as the first thing, we need to understand what is microservices. And one more thing that here that I'm not going to give a detailed explanation about microservices and other technologies that we are using underneath here, such as Docker and other container technologies. So I assume that you guys have some familiarity with microservices. Anyway, don't worry, I'll give you very brief introduction to these technologies. So the first thing that we are going to is what is a microservice, and why do microservices need orchestration? What is Kubernetes and Kubernetes components? And I have I'll be doing two demos. One is with local deployment, another one is with cloud deployment. And overall, this session is I would say like it's more or less a technical thing. So I would be like doing hands-on like demos and all, rather than going through deep theoretical aspects. Okay, so what we used to have right now, I mean, most of the products or most of the companies began their journey with monoliths, right? So monolith is, I mean, that is okay. That is okay to begin with monolith. If you are a startup or if you are doing a prototype of your product, so then everybody starting with monolith. So then this monolith is to handle because component that you need to worry about in a given time, and you don't want to worry about too much components, too many components, too many servers and all that. So you, whenever that there's a release comes, you do that, do your deployment and go ahead with your release in a one server, or maybe at least two servers. One is database server, another one is your application. So that is what we used to have. So then, the new thing came up. It's called microservices. I mean, this microservices architecture style is not a kind of like a new architecture style. It's been there for about 6 to 7 years. So if we define the microservice, it's called independently deployable services. That so in here, today's is independently deployable. So independently deployable means that we have a lot of service which can be independent and which is independent. Architecture taken from this microservices IO, you can see apart from a monolith, I mean we have a lot of services which is communicating each other in order to in order to cater the clients. In this case, clients are the mobile app and the web app in browser. So, so this is technically microservices. So, simply you can assume microservice as a lot of small independently deployable components or services. Basic features of microservices. So, organized around this capability is one thing. So, I don't know whether you guys might have heard the term called domain-driven DD. So, that is the main concept distributed architecture. Architecture. So with the distributed architecture, that you are at place a lot of there concept called policies of distributed architecture, because when it comes to distributed architecture, you have to think about the network latency, whether the the other nodes that you are working is are they working properly, or are they up or down? There are a lot of things that you need to concern when you are going into the distributed architecture style, such as microservices. And decentralized governance. The governance is also, I mean, whenever that you are deploying your application with the production, your components, your services are all around, in many servers, many nodes, and all that. So you cannot have a centralized governance. So there should be a decentralized governance as well. And independent deployable services, I think I have explained that thing earlier on. infrastructure automation. It is also very important. So, I mean, doing this thing manually, like managing or deploying these services manually is not, it's not possible. It is unhuman, more or less, right? In a regular monolith world, we have our infra team or network team or deployment team who is in taking care of the deployment and all everything related to release. But microservices, you cannot do it from. I think you guys have heard about the terms called CI/CD, continuous integration, continuous deployment. So you need to incorporate those things into your microservices architecture. Design for another very good aspect of microservices, because I mean, you don't know when something would fail. Whenever that you are writing a code or you are trying to deploy a independent service, then you have to think about the failure scenarios as well. You have to code, you have to make sure whatever service that you are writing is working when the dependence fail. So design for failures is doing that, and evolutionary architecture means that this microservices architecture is constantly rolling ahead. That means that there are constant changes into these deployable components. So you have to support that one as well. Fault tolerance and rapid deployment is also another thing. Our good old days, we used to have the regular. I mean, we once in a month or once in 2 months time, but it's like you can pretty much 2-3 times per day. I mean, as an example, if you go to Netflix, if you study Netflix architecture and how Netflix is managing their servers and all, and how they manage their releases and all, they are doing more than 50 releases, 50 production releases per day. So that is how the rapid deployment is there. So you need to care. I mean, when it comes to Microsoft architecture, you need to make sure that your architecture or your infrastructure or your software supporting these twice, you will end up in a disaster. Okay, so this is an extension of what I'm talking about. Can we manage microservices as a monolith? Of course, we cannot. I think we have discussed that thing already. Right, so manual deployments are out of the way, because you cannot. I mean, you cannot deploy 500 services in a release manually. By copying DLS, copying binaries, and all that. You cannot do that, right? That few deployment aspects in a monolith but microservice, we do not know how many, right? Scaling is another factor, right? Whenever that whenever that we are talking about the elasticity, when the request load is getting high, we have to scale it automatically. So those things are the I would say more or less not a drawback, but things that you need to consider when you're deploying containers application. So the approval I have the orchestrator for containers, right? So you can say Kubernetes is an container. See how that this is being done by Kubernetes. So Kubernetes is not like it's not a very new technology. It's been initiated by so first of all, it started as in the project called Vogue, and eventually ended up as Kubernetes as an open source product. So then again, these are some information about some theoretical information about Kubernetes. So you will get to know when I'm doing practical aspects of Kubernetes when you are doing the demo. Okay, so this is the basic Kubernetes architecture that we can think about. So we have mainly we have master. So master is the one that who is taking care of all these. I mean, in our Kubernetes definition files, we can say, I mean, we can tell that okay, we need at least 3 worker nodes for this particular deployment. So then master is the one that is make sure that the three in this C06. So whatever the number that we have defined, master is the one that the desired number of nodes are up and running all time. Right? And if you take a node, right, a node such as this, you can see that in this example, I have put it as a Docker, but this can be in any container. I mean, you can use any containerized platform in this thing. So I would the you have the proxy, which is outside interface, and the kubelet who is managing the node as well. So you will get to know more of these things when we are going into the practical aspect. And the other component hub to get down all our images and run on worker node. So in our practical aspect of this session, I will explain those things, how we can get it done. Right. So the most basic aspects in Kubernetes is called the pod. So pod is, it's a very simple thing. You can think a pod as a wrapper to a container. So in this case, I'm using a Docker container. So you have the Kubernetes cluster here. And inside the cluster, you can have more pods. And any one pod can contain more than pod is you can say a wrapper or an abstraction to the Docker container. So one bad usage of pods, you can have container when you have the pod and you have one container inside there, and you have hosted two of your applications inside the one container. I mean, you can do it, of course. There's no limitation for that. If the container, the resources supporting all these applications, you can do that. But it's a kind of like a bad practice because there's no, the separation of concern is not there, because if this container fails, both these applications is getting failed. And this is another bad usage of pod, that you have two containers. That is good, but you can of course host, as I told you earlier, you can host this in a one pod, but that is also bad, because there's a saying that you don't put in one basket, right? So if this pod fails, both these containers would fail. So this is the correct, like have one-to-one mapping, one container for one pod. So that is the standard practice of how you do the abstraction of pods. Okay, so all these examples, that I actually, I like to thank this guy called I'm hub repository owners public available, so his images or Docker images to create containers in my example. Okay, so now let's move into the practical aspect. So okay, so in my machine, I have used actually I'm using the Minikube. Minikube is very simple version of Kubernetes. Yeah, you can install in your local machine. So first of all, I can check the status of the Minikube. So it's running, so everything is okay. So then I will move into my file. Okay. So this is how I organize my folders in this practical session. So first of all, let's move into the pods, because now you guys know what is pods. Let's examine what is pod. So in Kubernetes, you can define a pod by using a simple YAML file. So I will cut this YAML file and show you how we can define the pod. Because it's very simple, right? So the first thing that we need to define here is the API version. So by default, as of now, most of the Kubernetes version 1, right, in your YAML file. And the kind, so this one is another important thing. So you need to define what is the artifact that you define in our case, support and metadata. Metadata is also it's kind of like a tag that where you can distinguishingly identify your code, the code that you are going to deploy. And this one is the most important in the container, right? So this one is the right. So whenever that some other pod or some other service referring to this pod, I mean whatever the application that you are running in this particular pod, this is the reference that they are taking. The name web app. So I'm using web app as the tag here or the label here. And the other thing is that the image. Okay. The other thing is the image. So I'm in the local hub and getting this particular image from this guy's Docker repository, right? So it's a simple Angular. So let's deploy this thing into our Kubernetes ecosystem. So I'm using the kubectl command here, and I'm saying apply. I need to define or dimension the file here. So the file is so it's now it's deployed. You can see that it's pod web app created. So now, as the next step, what we need to do is we need to make sure whether it's deployed or not. So you can do the kubectl get call command to get it done. Right. So you can see. I think I forgot to delete my previously pods. So I have more pods in it. Delete that. I'm going to delete all my previously deployed. Just can any organizer make sure that you guys can hear me?
Excuse me, Priyal. Yeah, there is a small break. I think it's better to turn off the video and just go through with the sharing only.
Hello, sorry. I dropped again. Is it okay now, Tushar?
Yeah, we can hear you now, but I think we need to stop the video. Stop the video and just share the screen only. Your camera, turn off the camera.
Is it okay now?
Seems to be okay. You can go ahead. Yeah, we'll see what's
Okay, thanks. Okay, so let me restart my kubectl so then we can start from fresh. I think you guys missed it because of the network connectivity issue that we had. Okay, so I have deployed one pod here. So let's get all these back again. You can see that the pod is running. So this is the pod that I yeah. So then let me the scroll down again. So I'll move it. Now you can see that this particular pod get the IP of this 172. So this one is only inside of that pod. So if I go back to my screen, my presentation again, you can see now kind of like a system that we are having or the environment that we are having. So we have deployed a Docker image or Docker container inside this pod, but there is no any way that outside the system, so I or any outside person can communicate pod because there's no interface being defined. So what is an isolated thing. So to get it done, so how do we know that this one is working or not? So what you can do is you can go inside to this pod and see what is in it. So to do that, what you can do is you can if you are familiar with Docker, I think if you are familiar with Docker, you might be familiar with this. So I'm going inside into this pod now. So in this pod, I have like, I can do the ls and all. So it's there. So what I can do is I can simply get a wget and localhost. And if I cat this index HTML, replicate we don't, I mean, there's no way that we can access it. So, I mean, this is not a practical thing. So let's see, we'll go in the next step and see how we can expose this web application to the outside. Okay, to do that, what we have is, we have something called services. So service is an, like something like an interface that that makes the pod available or the pod service available to the outside world. So, and there is, very famous saying in the world of Kubernetes that you have to treat your pods as cattle and services. So, what you expect pod to live, like, some pods are defined to live only for a few minutes. So that's why that we are saying pods are right. So, I mean, I think a little bit different. I mean, when it comes to countries like Asian countries, because there are people who as pets, but you know services are not like that. Services are we are keeping the services. So and then again, okay, I'll do the next exercise so that you can understand that. So this is what we are going to do now, right? So we are trying to define a service where it can expose our web app into the outside world. So when you are defining services, there are two ways that we can define service. One is by giving it as a cluster IP, and other one is giving the type as the node port. The cluster IP, if you define any service with cluster IP, then what it says is that whatever the service that you are going to expose would be exposing only inside this cluster. And if you want to expose this thing to an external application, then you have to define it as a node port. Right? So let's go into a practical and see how we can do it. So I'm going back into my services. So these are the two things that I have. So I have, first of all, let me go back into my code section and delete this thing. I will, okay. So then you see the so nothing is there. You can see that my existing code is terminating now. So let me explain what I have defined in this code YAML file here. So it would be more or less the same the pod that I have defined earlier. Right, this is an Angular application, and I'm trying to execute the release version 0 in here. So let's examine what's in the service. Okay, so in here you can see that now my the kind is changing to service, right? So in this web app service YAML file, I'm defining my my file type or file kind as a service. So earlier we had a file type as pod, and then the metadata. So how you can identify this particular service? So my code service. So in this case, I'm trying to I'm taking this label and I'm trying to access my my code that I have defined called the web app, and the release is that's exactly 0. So I'll explain this thing in a while. And it's also very important. Port. So what is the local port that you are running your service? That is port 80, because this one would be an HTTP application. And the node port. Node port means in what port that you are exposing your service to the outside world. And remind you that whenever that you are trying to expose any node port, more than the port num more than 30,000. So that is a kind of like Kubernetes.
Hi, Priyal.
Priyal, are you there?
There's another outage. I hope you can hear me.
Yes, we can hear, Priyal.
Okay.
Turn off
Okay.
the.
So, sorry.
Turn off the video camera and just share the screen.
Okay, sure. I hope the screen you can see now. Okay, so let's deploy this service and pod. So what you can do is, so I'm in this file. So if I do ls, so I have two files in here. So let's deploy this using Kubernetes. And since that I have two files, I can use the dot notation to deploy. So you can see that the web app and the service also created. So let's see what are the things that are available now. Okay, you can see that I have two web apps that is running. So let me explain that thing again before I show you what's going on there. Right. So in this pod, I have defined in this pod file, I have defined two versions of web application. So first one is this. So everything is same, except I'm using the tag 0 or the release 0. And I have defined another pod with the tag 0.5 and the release 0.5. So these are two versions of the same web application. So you can see that using this Kubernetes, we can live with two versions of the same application at the same time as well. So, but in at my services file, you can see right now it is trying to access only the release 0. So let's run this application and see what's in there. It would be a very simple application. So I'm to execute this thing. So what this command would do is it would create a wrapper and extender, and it is showing in the in our default web browser. You can see so that this is a very basic kind of an application. So what I'm trying to do here is, it is kind of like a GPS based application where you can track your vehicles and all. So that's a sample application that I'm trying to show you here. So you can see. So now let's see how we can swiftly move into the next version. In microservices, so this is one aspect, that you are rolling your versions very rapidly. So I'm going to stop this thing. And in the service file, what I'm trying to do here is, instead of release 0, I'm trying to take release 0.5. So that's all that I'm doing. So let's roll out this version as well. So apply F, and I'm going to access my application again. You can see that the release 0.5. So this is my previous application. So it's died now. So this, the web browser is still showing that. But this one is version 0 and this one is 0.5. You can see there are some enhancements into this application. So that is how you can expose, by using a service, you can expose your pod service into the outside world. Okay, so now let's move into the other aspects of our application. Right. So this is same kind of a concept that you have the service for the front end service and the back end service. So you have one pod in here and another pod or a cluster in here, one Kubernetes cluster and another Kubernetes cluster in here. So in this first Kubernetes cluster, I have 3 pods in there. So all these 3 pods are exposed outside world by this front end service, and the backend service being or the backend pod being exposed to the front end application by the backend service. Okay, so then let's move into the replica set. In microservices, the other most important aspect is having so many replicas, right, in one application. So because this is mainly for the high availability and for other aspects of load balancing as well. So let's go back to our practical aspects. So let's first of all, I'll try to delete this current deployment that I'm having. Okay, so I'm moving into my replica set folder. So let's I'll quickly go through these pod files that I'm having. So it's the same pod for the pod file. I have the same application, and the most important thing is that now I can define the replica. So now I have something called spec. This highlighted part. In here, I can define how many replicas that I am going to have in this pod file, right? And the labels and all others are remain same. There are very minor changes because of the time constraints. I'm not going to go through everything. So let's describe the service file as well. Okay. So in here, it is more or less same. So I have the selector. So since that I'm no, in this case, I'm not going to mention the version that I'm trying to expose. So all the others are same, and this one is also type of node port. That means that you're trying to expose it to the outside world. Okay, so first of all, let's make sure that there's nothing running in our Kubernetes. Yes, nothing is running. So let's deploy this thing. Okay, so let's see what's been deployed there. You can see that there are 3 pods are running now because the reason is that in here we have mentioned the replicas as 3. So there are 3 pods are running as depicted in my slide here, and this one is exposed using the node port. So if there's another command that in get all, so you can get pods with switch wide. And in here you can see the IPs that these pods are running as well. Okay, so in here, so like that, likewise, so you can define the replicas as well. So let's try to delete one of these pods and see what's happening. Let's say there's some kind of application crash and all, so pod is getting wiped out. So let's simulate that one here. So I'm deleting a pod, right? Let's say, so I'm trying to delete my first pod here. But this ended up with HQP. Okay, so it's deleting. So let's go and see what's going on. See, even before we execute this command, it spin up a new pod. You can see that this the pod that is ending up with LZW was not there in our previous replica set, but other 2 were there. You can see that how quickly in a crash situation that the Kubernetes can spin up a new pod, right? So this one is another important aspect in microservices as well, because you are using microservices, and by design you are designing it to fail, right? So if there's a failure, there should be a quick spin-off of a new instance. Okay, so let's delete this one as well. So let's moving into the other aspects, that is called the deployments. Delete here. Make sure that nothing is working here. And so nothing is working, so I'll quickly move into my deployments folder. So then again, I have 2 things here, 2 files. So let's describe the code file here, right? So then again, it's more or less like same thing. So I have introduced a new concept here, that's min ready seconds. That means that you are make sure that before you ready a new pod, or if there's a failure, there's a 30-second gap. So normally in a production environment you are not putting this thing, but today I'm applying this thing just to make sure that our demo is working correctly. So then we have time until the new pod is turning on. Okay, so let's deploy this thing, and we have that like 3 replicas in here. So let's add the service file as well. Okay, so the service file is also more or less the same. Everything is same, like that we have selecting the web app, and the kind is service here, and this is the service name. So let's go and see how this is happening now. Apply. Okay, and we'll see how the things are turning up now. So you can see we have 3 pods are running, 1 service, and 1 replica set, right? And actually 3 replica sets are there, and 1 deployment. So the main difference between the deployment and the replica set is more or less like the same concept. When it comes to deployment, like you have some kind of a versioning doing by the Kubernetes itself. So in order to do that, let's see how the versions or the history that you can have in here, right? So first of all, let's see how you can see the status of this deployment. I'm trying to get the status first. Okay, so my deployment name is Webback. Okay, so successfully rolled out. Okay, and there's another command that you can get the version or the history of this deployment. You can see that we have one revision, and if I cut my my pod file here, you can see that I have released the latest version of the 0.5. So let me go back one version here, right? So now instead of release 1, I will be doing the release 0 here. Actually, it should be the other way around, but let's assume that you are rolling back here. So I'm trying to apply this thing again. Okay, so web app configure, that means there's a change going on. So, okay, now you can see that we have the two versions here. So first of all, let's go and see what is the service is being exposed now. YouTube service. So my service is this one. Okay, so I'm deleting all my previous one. So this is the current version that I'm running on, right? And so let's see now what I'm trying to do is I'm trying to roll back to revision 1. So now we are at revision 2. So now we are trying to roll back into revision 1. So we don't want to do anything. So what we can do is we can do kubectl rollout undo. So undo is the command. Deploy back to revision 1. So now we are at revision 2, and let's see. Now we are trying to roll out the revision 1. Okay. So let's say let's now go into the status of this rolling out. You can see that it's been updated. So it's taking this much of time because I have put that 30-second gap in there. So what I'm trying to do is I didn't make any changes here, right? So I'm trying to browse the same application in the incognito mode. Otherwise, the browser is using cache and we cannot get. It still is not up. Okay, so we'll wait until the rollback is finished. Okay, so it's finished. So let's open up that service again and see. If you you can see that it's been rolled back to the first deployed version, right? So you can see that in a microservice, let's say that whenever that you are deploying your application, and if there's a problem, so quickly you can roll back your versions very quickly. Without doing any deployment. So we didn't do in deployment here. We just roll back using the rollback command in Kubernetes. So you can see, how quick it was, right? And okay, so that is it for the local deployment. So let's move ahead. So this is the local architecture. So I'm not going to go, since that we have only 10 minutes remaining. I'm not going into that. So let's go into the Kubernetes cloud architecture that I have. So this is the fully fledged web application that I have here, right? And here, if you wonder how you can deploy this thing into cloud architecture, so this is the reference that let me close this. This is the reference that you can use, right? So this is, I mean, yeah, I have used the concept called COPS to deploy. So I mean, you can get started with COPS on AWS, so you can do it, deploy Kubernetes using COPS in AWS, GCE, and all that. DigitalOcean and all. Unfortunately, Azure is not there yet. So if you want to deploy Kubernetes into AWS cluster, so then it's very simple. Just go through this guideline, and you can make your Kubernetes environment ready in AWS. So this is the environment that I have, made ready for this demonstration. Okay, you can see that I have refresh. Okay, I have like three nodes here, right? Three physical computers, or three physical nodes here, and I have one master here. So this is if I go back to architecture, so these are the three nodes that I have. I have deployed my web application API gateway in one node, and position tracker and Mongo database in another node, and ActiveMQ and position simulator in another node. So this is how I began my setup, but I had to do, I mean, some restarts and all. Then these nodes, right now the node, this ActiveMQ might be in this particular node, and that happens because it is automatically provisioning. And I have the mask node here, so there are no any operational aspects in this mask node. What it is doing is just make sure all these nodes are up and running. So this is my setup in AWS. So first of all, I have one load balancer here. So let me explain what this application is all about. It's a very simple application. So I have this load balancer. So this is a front-end load balancer which exposes the application to the outside world. Okay. So this is the application. So you have all your vehicles here, right? And this one is live. So what what is it doing is, it is this position simulator. It has previously recorded few set of GPS coordinates for many vehicles, and it is publishing that thing in random intervals in this ActiveMQ, and the position tracker takes that and persisting that thing in the MongoDB. So I have used AWS EBS as the the hard drive of this MongoDB server, because that MongoDB, this one is then again a pod inside the replica set, so it can go off on and off at any time. So I need to make sure that there is a persistent storage into my data, and the web app is the thing that you have seen in here. So this one is accessing this thing using the API gateway. Okay, so if you select one particular vehicle, you can track it. I mean, there's a red color line being drawn in here. Right, so this is the architecture that I am having. So let me quickly log into my AWS. Yes, I'm going into. Yes, so let me SSH into my Okay, so I have a few config files here. Let me go into the config file. Then again, at this point, you might be familiar with this thing. So all my pods are defined in the workload YAML file. So this one is a bit of a long YAML file now I'm having here because it's kind of like more or less a production grade configuration. And I have several other YAML files as well, which is related to this. So let's first of all examine what are all the pods that are running in here. Okay, so I have so many pods that I have explained in my architecture diagram as well. You can see that it is being distributed among 3 nodes that I have, 3 IPs, right? So these are the internal IP addresses in here. So let me do a very simple demonstration here before we close. I think we have only 3 minutes, right? Actually, I plan to do many other demos in here, but the time and network connectivity made us into a bad day. Okay, let's go to the worst case scenario, right? So if I go back into my AWS console, right? So one thing that can happen is I can get, there might be a crash in this node itself, this physical node, right? So let me crash this thing and terminate it, simulate. So now we are terminating a physical machine, it is, it's a very bad in the production environment. So let's see what is happening. If we go back into our application, you can see that still is running. So there might be a place that, everything get hangs. You can see that this truck has stopped running, right? And our server is shutting down. So let me refresh. I think still is shutting down. We'll wait another 1 minute or so. So what I'm going to explain here is that, even at a physical node failure, Kubernetes has the ability to spin up new physical node and distribute all your pods and make sure the application is running. So still the application is failing. So this is kind of like in a several situation. A typical situation where your system fails at 3 a.m. right? Your network administrators, your DevOps team is on sleep. There's nobody. Maybe there's support guy, only a L0 support guy who can answer only phone calls. These are kind of a situation that can happen in real world, in real life. So let's see what's going on. It might take some time. Okay, so now this one is terminated, right? I think we have to wait a few more minutes. Okay, so now let's examine. You can see that new service coming up now, right? You can see it's pending, right? I think the IP, the local IP might get assigned. You can see that it's running so quickly, and it still is initializing. The instance is running now, and it has a new IP as well as the private IP 169. So if we go back into our console again, you can see that there's no IP ending up 169 earlier on. So let's examine our ports again. You can see that still is not been updated, right? We have deleted one. Still is not been updated. So still server is spinning up. Right. Eventually, what would happen is that when that node is ready, the server 169 should be there. I think we need to give it like 1 or 2 minutes time. So the idea is that the application would run even at a physical level hardware failure. The Kubernetes makes sure the application is running, right? So still is gets stuck. So when this thing came up to life, then we would be able to see the vehicle is moving, means that our application is working correctly. Till is initialized, so it will take another 1 or 2 minutes time. I think this one doesn't have anything to do with. I mean, this time doesn't have anything to do with the Kubernetes. It's entirely AWS thing. But I hope you guys got the idea. So we'll try one more time. This one there. Okay. Okay, guys. So I hope you got the power of you at least get a glimpse of power of Kubernetes in your production environment, what it can do. And this just I would say that this is not a very deep introduction or very deep explanation about Kubernetes. There are many more things that it can do. It's just scratching the surface. So I hope now you got some idea what we can do to our microservices using Kubernetes.
Hi Priyal, we have a couple of questions asked from our audience.
Okay.
One is we can define replica count in kind deployment. Why we should use kind replica set to define replica count? What is the difference between both kind?
So I didn't get it clearly.
Uh, I repeat once again.
Okay.
We can define replica count in kind deployment. Why we should use kind replica set to define replica count? What is the difference between both kind?
Okay. It's like this, right? I mean, you can define. In our example that we have used the normal pods, the services, and the replica sets and deployment, right? So replica set is not a deployment. I'll come into that, right? Replica set is something that assume that you want to have some kind of some service set of pods that which is not a deployment, right? That you have some kind of a distributed replica sets, or sorry, distributed pods in a replicated environment, right? And you cannot, with the replica set, you cannot do things which we did with deployment. As an example, the rollback or go into a specific version. You cannot do those things with replica set. It's just merely a replication of your pods, right? But technically, I mean, in terms of your deployment, the replica set and the deployment is more or less like same. The advantage of deployment is that you can do things like switching in between versions and rollback, and get the status of the rollbacks and those kind of things. Those kind of things. So in production environment, we are hardly using replica sets, but deployment, because deployment sets automatically define replica sets based on your number of replicas that you need.
Yeah, we have another more question. How to set up a multiple environment like dev, QA, staging in Kubernetes?
Okay, that is also a good question, right? Okay, it's like this. Now, what you can do is, multiple environments. Multiple environments, normally we are defining a Kubernetes environment for one particular environment. Let's say, for example, a QA, production, or pre-prod, right? I mean, in Kubernetes, there is a kind of like, I would say, a standard that, you should not have two environments in one Kubernetes cluster or one Kubernetes environment. The thing is that easily, you can switch. I mean, your pods can migrate here and there, which is not good. So easily, what you can do is in your, Kubernetes normally we are using CI/CD pipelines, right? So in your pipeline, when you define the pipeline, you can use a tag system or tagging with your container repository, right? So as an example, you can have you can tag your containers only by QA. So whoever the DevOps guy that who is deploying into the QA, that his job is to make sure that going through all the pods files, deployments or whatnot, everything, and make sure all the tags are defined only to, only tags that is defined in that file only refer to the QA environment, right? So, in one container in repository environment, you can have many tags, you know that, right? You can have many tags, but it's all about the deployment, right? And to answer your question very briefly, do not in a production environment, do not mix two environments in the sense the production, pre-prod or QA into one Kubernetes deployment. There might be information.
Yeah. So one more question asks, what version of Docker are supported?
Well, almost like all the current versions of Dockers are supported, except maybe old ones, right? In here, in my because in these exercises that I did, I have used the latest version of Kubernetes and the latest versions of Docker. Technically, all Docker versions should support.